Assalamu alaikum, everybody. My name is Sadif. I'm from the COMEX exhibition and conference. It's a pleasure to have such a big number of speakers and a large panel today. The topic AI and information and cybersecurity has been one of the top topics with AI, with such a advanced technology and the sensitivities and the security and information associated to it. We have a very strong panel today. So I would like to introduce our chairman of the session, Dr. Sheng-Chuan Wu. Dr. Wu is the vice president of a company called France Inc. He's currently based in San Francisco, USA. Dr. Wu would be the first speaker as well of this session. Then we've got Ola Lindt. Hello, Ola. You're the director of Dotlines. You're currently based in Dubai. Then we have Said Al-Bahri, senior specialist of the Cybersecurity Center in the Sultanate of Oman, established by Oman Data Park company. Then we have Aideen Aslaner. Aideen is the head of security of Middle East and Africa, currently based in Dubai. Then we have Bilal Isa. He's the technical lead from 10 Micro. He's currently based out of Qatar. I always admire his screens and his gadgets, so that's awesome always. Then we have another speaker now connecting. I'll just wait for a second. Hello, is that Ayman?
Yeah. Hi, everyone.
Yes, Ayman. Assalamu alaikum. It was your turn, and at the right time, your screen popped up. So I've just introduced the chair, Dr. Wu, and all the speakers. Now I'm introducing Ayman Hamoudeh. He's the senior operations and response leader at IBM Security Systems, based out of UAE. So without further ado, I would like to request Dr. Sheng-Chuan Wu, Dr. Wu to deliver his presentation. We will listen to him, then we'll listen to all the speakers, then Dr. Wu chair the question answers and panel discussions. This would go a little longer than 2 hours, and I hope that's okay with all of you. So if all of you can keep to the 20 minutes time for the presentation, then I think it will be good for all of us. Over to you, Dr. Wu.
Thank you, Sadi. Let me share my screen.
Sure. Also on the panel is Amar. Amar is the CEO of the COMEX organizing company. And he's here with us as well.
By the way, Sadi, my share screen was disabled by host. Could you let me allow me to share the screen?
Yes. Is that enabled now, Dr. Wu?
Yes, I can do it now. No problem, no problem. Everybody can see my screen now?
Yes, sir, very much.
Good. Okay. So today I'm going to talk about how to use artificial intelligence to detect social media influence. Social media influence campaign is a major information security problem. In the 2020, if somebody started an influence campaign against a company, against a product, it can do very serious damage to the product or to the company. If people don't like some policy from the government, again, say they can start another campaign. In the US, there's quite a lot of people is against vaccination. And so they will start campaign talking about bad story about vaccination and then try to generate the popular sentiment against the specific policy. And then influence campaign on the social media can really change the social discourse, the social conversation, especially in politics. Well, for example, in the US, even today, there's more than 30% of people think that Joe Biden stole the election. And this is certainly is not a good social discourse. So the issue, though, how do we detect this influence campaign on social media? And there's the main issue is there's tremendous volume of discourse on social media. For example, in the month of May 2020, there's 6,000 tweets every second and 500 million tweets sent every day. It's a tremendous amount of volume. Majority of these posts are harmless. Some, have no resonance, just one off. But some malicious one could really bias the public opinion and incite violence. So the question is, how do we identify this malicious discourse wave, and how do we separate, this one from all the other harmless one? 95%, 98%, majority are not very, very harmless, but we want to identify those malicious ones. So the volume of the information is too huge to process manually. You want somebody to go through to check every single post. That's impossible. So we need to engage computer to help process the data. And how do we do that? First of all, the discourse wave identification started with analyze all the individual posts. So you get all these, as I mentioned, 500 million posts come through the internet, the social media, in the case of Twitter, every day. And so you will have the computer to process individual posts, extract some of the important information from each post. Most important now, you extract information like user, who published the post, who replied to the post, who shared the post. And more important, you want to extract the topic of interest of this post, specific post. If they talk about cooking, so you say it probably is not important, you just archive it away, put it away. It talk about hiking, talking about movie, probably it's not important. But when they talk about something that, when they start mentioning about, say, Sheikh Issa Air Base, then this may be something in there. You want to pay attention to it. So you extract all this metadata of individual posts. And after you extract the post, you are going to try to connect a conversation, identify the discourse wave. Discourse wave means the conversation within the Twitter space, all these posts connect together. The simplest method to follow, to identify discourse wave is to follow the reply to, like, share, retweet chain. Just follow the chain and you will find a conversation, a discourse wave. But this kind of discourse wave, it's not as important. Us try to identify the discourse with similar topics or similar entity discussed. For example, again, say, if a lot of posts, a lot of conversation that talk about this Sheikh Issa Air Base, then that's something, this is a group of conversation that relate to each other. If a lot of conversation talk about vaccine, talking about particular vaccination, you want to group these together. And so we use the cluster mechanism to group similar posts as a discourse wave, similar in topic interest extract, similar in entity discuss, group of actor or certain time window, certainly within certain time window. Such discourse wave are much more useful in detecting influence campaign. Traditional machine learning clustering algorithms such as K-mean do not quite work for this kind of clustering, for this kind of data. And the reason is that because traditional machine learning is designed to work with Euclidean data, means that data can be represented in the n-dimensional linear space. Things like image, voice, video, words, sentence, document, these kind of things you can represent in n-dimensional linear space. and traditional machine learning work quite well with this kind of data. But for graph data, it cannot do the clustering or machine learning well. So now equity data cannot be easily represented as data table, like the traditional all the machine learning use data table as an input. So you would say, for example, try to classify group based on the friend and enemy of their friend and enemy. You can go continue going down that ways. And so basically here we are not talking about the connection. We're talking about the context of the connection. So we talk about friend, we talk about family, we're talking about enemy, things like that. So discourse wave, a graph, it's not a table. So you try to use traditional machine learning, try to cluster all these posts to identify a discourse wave. It doesn't work out too well. So a new machine learning algorithm is called graph neural network. It's designed specific for this kind of non-Euclidean graph data structure. Social media network, you want to find a topology or cluster, and graph neural network is designed to do these kind of things. So in social media influence campaign, specifically, you want to identify those people tend to be affected, their opinion affected by the action by or the friend or the in-group. So graph neural network is designed to identify such cluster. And so we use this kind of new algorithm to be able to identify cluster in a much more meaningful way. So here's a sample. We just have about 1.2 million unique users. This cluster, this group of sample data, 1.2 million unique user and about 21 million connection. And so out of this, majority, 95% are not very interested. But there's certain cluster represent user with similar post, rewrite, reply behavior. And this is the screen that shows that using graphical neural network, we can identify it will identify a cluster. If we zoom in one of the small corner, and this will be the kind of group of the conversation, the post that talk about similar things. And this is the kind of cluster, this kind of group that will identify a discourse wave that for certain purpose, maybe good, maybe bad. So after we identify all this, we identify a discourse wave, a cluster, then we can start extracting certain metadata from this discourse wave and things like agenda. And particularly, there's a lot of malicious discourse wave. It's using computer bots. So we want to identify those discourse wave that created by bot. And then, what their concern, what their emotion, identity, all this metadata, we want to extract it from the discourse wave. And here's a sample metadata model, that the kind of information that you want to extract it from the post and also from the discourse wave, the conversation. And because the huge volume of the processing, the post, the discourse wave, we need to use parallel processing. And then, because every post could be connected to another post. So all these metadata need to be, shared by all the other analyzer. So for example, here you have all these post analyzer. They will extract the metadata, the information about the post, it put into a metadata database, what we call a single source of truth. And then when you decide when the time comes to get to invoke the clustering algorithm, graph neural network algorithm, to identify the discourse wave, you need to access the same metadata. So which post connect to which post, because they talk about a similar subject, because talk about the same agenda. So when you extract the discourse wave, you also want to identify a discourse where you want to extract the metadata, again, say metadata from the discourse wave. And you can think about here is that all this processing, because tremendous volume, you have to have many processes to process the information goes through the internet. And they all try to access the database, write information there, access information, will create access contention. And that's not scalable. At some point in time, it will be slowed down. Not the computer, not the individual node slowed down. It's because everybody waiting for everybody else to access this metadata database. So a better way to do this is we use a scheme called multi-master replication. It's basically everybody, every analyzer, every process, every computer process have its own database. So, but every database will be synchronized automatically. In other words, it's that every database, it's a primary database, but it's also a replica of all the other database. It will be synchronized by the computer automatically. So by the time that you want to fire up the graph neural network clustering algorithm, its database, it's already synchronized with everybody. So there will be no access contention because everybody will not wait for everybody else to access the information from the single source of truth. So after you identify the discourse wave, one of the, especially these days, one of the most important tasks is to identify, is this conversation generated by bots? Because bot can generate a lot of conversation, and you want to identify those conversations. And there's many algorithms to identify if this conversation is it's created by computer bots, and some one of the algorithms is particularly effective. That's using the Ascii model for ferromagnetism, and basically the computer bot will exhibit a behavior heterophily behavior. Basically, bots usually will not respond to another bot because it's generated by the computer, not by human. And so this heterophily behavior is, the Ascii model is specific to identify this kind of behavior. And then you can use other statistics like Boltzmann statistics to compute the bot scores. And we do the experiment, and it's not only faster, compute faster, that's important because of the volume we are processing. It's more precise than barometer that used widely by academia, and also all bar or not, the public available service will do a test against those things. And the Ascii model work better than those things. And then you extract the worldview, the interest of all those discourse wave. And then there's many dictionary allow you to help you do those. And then you use the zero-shot learning algorithm to extract all the context of when they use certain words. What is the context the most suitable for that conversation? And then when you identify an influence campaign, a discourse wave, you want to identify the target worldview group, the most susceptible to the attack agenda. For example, in the US, there's many people very hesitant about vaccination. And, they're not sure if vaccination is safe. People, they're not necessarily against vaccination, but they're hesitant. And this is the target audience that if I want to start anti-vaccination campaign, then I will tell them that, do you know that out of those people that will get vaccinated, there's more than 4,500 people die. But what they will not tell you is that there's more than 150 million people that are being vaccinated. Out of that, there's 4,500 people that die. But that compared to normal circumstances in 2018. So the percentage was 0.0017. Perhaps there's nothing to do with vaccination. People will die for a variety of reasons. For example, in 2018, 2.8 million people die. Disease, getting old, without the help of vaccination. But they will not tell you that. They will just say, do you know that there's 4,500 people, almost 5,000 people die after vaccination? And for those vaccination hesitant people, they are most susceptible. You want to identify those groups. And so you can devise a counter strategy. Maybe you want to send out and follow those tweets and present like what I'm presenting right now, that may have nothing to do with vaccination. And then you also want to measure the effect of the attack, the change of level, the activity, more people joining, the emotional intensity, that kind of thing. You want to extract those information. In summary, influence campaign attack using social media is a major concern in today's business and political discourse. Especially in the US, the political discourse is totally influenced by social media campaign. There's tremendous volume of data. You need an architecture to be able to process these kind of things effectively. Otherwise, you will never be able to identify the malicious one. So we employ innovative algorithms like GNN, the ancient model, for identification and classification of suspect and malicious social media discourse. And so hopefully that we'll be able to counter those malicious ill intent influence campaign. Thank you very much. And Sadia, could you move to the next one? Who is the next one?
Yes, yes, Dr. Amar. Can't see him. Sure. Our next speaker, I would like to introduce Ola Lindt. Ola is the director of Dotline's company. He's currently based in UAE, based in Dubai. So Ola, if you could say a few words about yourself, what you've been doing, and then start your presentation, 20 minutes, and then we can move to the other speaker. All over to you, Ola.
Thank you. My name is Ola Lindt. I'm the business development director of a group in Singapore. We are an 1,100 strong team, and we are in 12 different verticals, all related to mostly digital services, products, and innovations. And one of them that we have been developed for the last few years is do-it-yourself firewall and solutions. And now we have a full suite from home device to enterprise solutions. But what we have done for home, small businesses and so forth is we have made it simple. So meaning that you do not need to hire an IT professional to run your firewall in your small, medium business. Anybody, even the boss, could run it from his mobile phone, and made in a way that is very, very user-friendly. So we have taken a different approach. In today's presentation, I like to present something that we have done a case study regarding cloud-based firewall. I'm trying to open my Zoom here so I can Sorry. I'm not able to open up here.
Okay. But you have the ability to share. Just click on share screen, Ola.
Yeah, I'm trying, but it's not actually giving me the screen at all. Hold on. This is the beautiful thing when you're live.
We're learning a lot. Life is not easy. Yeah.
No. Okay.
It's Murphy's Law, as they call it.
Yeah. Let me see. It says error in Zoom here. That's my problem.
Okay. Do you want to send it across to me, Ola, so I can show it from here?
Yeah, but I have a problem of opening up the screen here. It says error in Zoom. Hold on.
Okay.
Let me. Now I can. Hold on. Now
Okay.
it's working.
Great. Yeah. It's all about timing with online.
It always.
No, they have the wrong firewall, I'm sure.
Have to be. All right. So let me go into the presentation. So regarding firewalls, ISP operation, we are talking about internet service providers. We actually have a case study that we implemented 18 months ago into an existing ISP provider in Southeast Asia. And one of the biggest problems was that they were growing at a very high rate. And their problem was that how to be able to better serve the customers and in the same time reduce the cost. So by implementing an AI firewall that is cloud-based, you have a different kind of approach and a different way of actually going and reducing time to detection and to prevention and to do something about it. In a normal case, when it comes to a typical DDoS event, and this is the biggest problem an ISP has today, because they have on average globally around 500 DDoS attacks on their core or network per month. And this makes it very problematic in the sense where they need to solve and spend a lot of money and attention to. So normally what happens with a zombie network attack is that they go straight on to their ISP and they try where their vulnerabilities are to influence. And that can be anything from that the network goes very like an end user that has the problem that cannot understand why the network is so slow, or there is some typical things where it happens within the core for the local ISP that creates a lot of problems. So this is what happens in a normal, on average, every month when it comes to operation for an ISP. So the biggest problems they have is the bandwidth congestions. And this is not only the problem for the ISP, it also becomes the problem for the customer service and for the end user. Because as soon as the congestion starts, the end consumer will start complaining, calling the call center or the customer care, and it creates a lot of additional work, costs, and disruption of service that the ISP gets penalized for, in the sense of that customer do not like them, they might switch to other network operators and so forth. TCP attacks, that is the most critical ones, means the network goes down. And afterwards application attacks, where it's very difficult for the ISP to solve the issues. So there is obviously then major business impacts on an ISP and so forth. This is just a few kind of stats, and I'm not going to go into them because it's not the most important in this factor. But when you run an ISP network and you have inline firewalls, and that means that you need to process everything in your own processing. Means that you need to scale, cost money, and it's harder to handle because the reduction of capacity happens when you process, and it makes a lot of more capacity is needed to run, specifically when you scale an ISP, especially during the pandemic, when all the ISP actually had so much more usage than normal in the home area and not in the business area. So three of the most important part to do for an ISP when it comes to operation, when it comes to attacks and security. One of them is that you need to detect and analyze what happens. After that, you need to respond and do the recovery. And afterwards that, you need to do post-incidents, meaning that you need to be able to do these steps each time there is an attack on your network. So by running manually or doing an inland security solution, this can take a lot of time before you actually detect the attack itself. It can go hours, it can actually go days. And so therefore, this is the major concern for all the ISP operators today. So cloud-based firewall brings a different way of solving these kind of issues. So it's all about threat management, how handling it, threat intelligence with artificial intelligence, meaning that you need to teach your network how to be smart and automate it. The more traffic goes through, the smarter it gets to analyze all the data that goes through and to make sure that the right decisions and implementation notifications takes place. At the same time, you have the cloud central, meaning that the operator needs to have access to all this data and all the answers in front of himself to be able to monitor reports and take actions. So threat management in an AI-driven safety net. It's all about detection and mitigation. Means that you need to understand what's going on, what's happening, and take actions. The DNS firewalls and response policy zones, meaning what are you in your network needs to be secured. And then the user behavior-based suspects group. And this is where the AI makes everything so clear for the operator, because it can very easily understand after it's been trained in the beginning to understand this is not a normal traffic pattern that is coming into the network, and therefore we need to take action and utilize the response on these specific actions. So we see that in this specific way when it comes to an ISP, holistic data analysis is very important. It's about self-learning the process, normalize, analyze, and benchmark data. And this is in the beginning for an ISP has to be part automated, part manual, because you have to train your engine how to operate. Obviously, in the beginning, this is a little bit hazard for any operator, but as soon as it has been established its protocols and its the points, it then automatically is on a wave engine to run the operation 24/7. So the benefit of the cloud central benefit is that you have the management panel, you have the rules management that you set, and then it automates the processes, the monitoring and notability that it will tell you, this is happening, we have a threat, what are the actions to take, or should it be automated taking action at the point? That is a choice that they have as an operator. Mostly in the beginning, everybody does it manually because they don't trust new technology. So when the trust is in there and they've seen and utilize the data, then the automation process gets more and more automated in an operation. And that you can scale it. And this is the most important. When you have inland server capacity, to scale it costs a lot of money and it's a little bit more problematic. When you scale in a cloud-based firewall environment, you can do it very quickly, and the data processing just not happen on your inland servers, meaning that the scalability is very easy and the data process can double, triple, and quadruple very easily without any major impact on your financials. And then obviously the reporting and analysis that is 24/7 at your fingerprints. So it can protect in full way because it's AI-driven detection and protection. and this is the most key part. Its self-learning mechanism and the algorithm makes sure that your ISP network always get more and more intelligent and takes care of threats at the time when it happens immediately, and that it's 24/7, and that it's simple management for the ISP operator. So here is the test case that I'm actually presenting. This was the biggest problem for this ISP at the time. And this is real information, what happened under certain of these kind of attacks. They all range from 48 hours to a few hours. And it's not just that you actually see that it happens, because sometimes that can take a very long time. And then the required time to resolve the issue can also take a very long time, depending on the complexity of the issue. So imagine having an ISP operation and you have a threat and it will take you 48 hours, 2 days, 2 full days and nights to complete and resolve the issue. Imagine the user experience in that case. And as an end user, if your network is down or your internet is congested and you not can be able to do any streaming at your home, etc., it puts a lot of pressure on the call center and the customer care, because immediately for an ISP, when the network is not operating at its prime, every user that is affected will contact one way or another, if it's social media or it's through the portal or it's direct calls to the call center, meaning putting a lot of pressure on the manpower or the resources of the ISP operator. So by adding as this special way of utilizing AI and this thing, it went from days to minutes to actually resolve and take action and have everything in place. So we are talking going from 48 hours down to 30 minutes, even 20 minutes to solve issues, and totally automated through the cloud firewall AI. And this is where we see AI in ISP operation critical in this way, because it's all about, obviously, to secure the network and the operation and the core of the ISP. But most importantly, I believe, is to protect the end user and also his experience with you as a brand of an ISP. Because that's the damage where it first comes when something doesn't work for an ISP. They say, oh, that ISP is very bad because they don't take care of customer care, or the network is always down, or is always congested, etc. So AI, specifically in this environment, is, I think, critical and is a very good demonstration where AI really makes sense in a internet service provider business. Thank you very much. I end this presentation here.
Thank you so much, Ola. Ola, are you able to stop the screen share? Excellent. Yeah. Yeah. Great. So now I would like to introduce Saeed Al-Bahari. Saeed is a senior specialist at the Cybersecurity Center. This is a initiative of the Oman Data Park, and Saeed is going to present to us. Saeed, if you could briefly introduce yourself and then deliver a 20-minute presentation. Over to you, Saeed.
Thank you so much. Hello, everyone. I think I have a little bit of dim lights around here. I'm not sitting. I'm not sitting like in a nice place like Dr. Shin is sitting. He's sitting just next to the Golden Gate in San Francisco. So unfortunately,
I can assure you, I'm not near Golden Gate Bridge.
Yeah, you have a nice background. So I'll start a presentation. Actually, I'll share my screen in a bit. I'll just introduce myself briefly. I'm Saeed Al-Bahri. I work in Oman Data Park Cybersecurity Center. I joined in 2017. I have a bachelor's in digital forensics from the United States. And I got into cybersecurity. And I have been working on improving our operations in the Cybersecurity Center. And we have approximately more than 300 customers. And we manage their security operations on a day-to-day basis. So today I'll be talking about how we can use AI, or how can AI help us in detecting malware. And I'll share my screen just to start the presentation. Are you guys able to see the screen?
There's an option to do the slides at the lower part of your screen. Yes, yeah. Lovely.
Okay.
Great.
Yes. Okay. So I basically my discussion is about machine learning and malware detection. So I'll go through what is malware, and I'll go through the traditional AV, how they work, and their their disadvantages, of course, and how we can improve on that using machine learning. So a malware basically is a file. It's essentially a file at the end of the day, and it does something bad to the network or to a computer. And malware can be in two states. It can be, of course, in a static state, or it can be running on the machine. And this is important for machine learning because we can do machine learning for, we can do malware machine learning in two scenarios. We can either run the malware and see what it does exactly in a sandbox environment, or we can just analyze the static file. So basically, the static file is essentially, it's like a book of words. At the end of the day, malware is essentially it's code, whether it's assembly code or C code or whatever. So we can do machine learning based on either extracting vocabulary terms or like words, or they call it features from the file, or we can do feature extraction while running the actual malware. Okay. So before we go on to discuss how to improve antiviruses with machine learning, I'll explain how the traditional ones work and why they are easy to be bypassed. So the traditional AV, actually, they work mainly in three approaches. So the first approach, and it's one of the most famous approaches, is the heuristic approach. In the heuristic approach, the antivirus, it looks at some features of the file. It looks at like the size of the file. It looks at what kind of functions is the file using at that time, and it looks at the permissions of that file and all of these things. So this is obviously it worked in the past when malware was basic and it did some basic stuff, but now it got really got more complex, let's say, and attackers, they improved a lot. They knew how this AV works, and they try to basically work around them. So in the case of like the attacker could potentially understand how the heuristic approach works in an AV, and he can change one feature of the file, and that feature could potentially ruin the whole detection and makes the detection fail, and makes it useless, basically. And this is one of the bad things about heuristic approaches, and this is why it gets bypassed easily. The second one is the behavioral analysis. And the behavioral analysis actually is not practical. Why? Because the malware must actually run first at the machine. And that is not something we want to have. Of course, if the malware runs in the machine, that means the damage is done and that's it. We cannot do anything about it. So it's not good for us. So it is not really practical to do that in an AV product. Some AV products, they do behavioral analysis, but they do it in a sandbox. But the problem with that is some malware, they have, especially advanced persistent threats, they have some anti-sandboxing mechanisms. They understand that they are in a sandbox and actually they don't work. They will not work like normally what they will do in a normal production environment. So this is one of the things that they have to, the AV products have to pay attention to. And also the third one is hash-based approach. The hash-based, of course, it's the simplest one. We have a set of hashes, set of malware hashes, and then once we install the AV in that machine or a server or whatever, it will start calculating hashes for the files in the system, and then it will compare it between the database. And if it finds any hash, then it will quarantine the file. But the problem with this is the hash-based approach, you can easily bypass by changing one bit of the file, and then boom, you will have a new hash. No one has seen that hash before, and guess what? It will work, and the AV will be like, it will not know what's going on. So this is why we need new ways to prevent malicious code from running. And in machine learning, there are some predictive approaches where we can prevent the code from execution. And there are the problem is there are new types of malware that we need to pay attention to. Some of them is fileless malware, which doesn't save anything to the disk. So how are we going to do that? How are we going to stop such malware from running, which is really challenging? So we need to have AI, and we need to have smart pre-execution predictive models to stop such attacks. So to do malware detection using machine learning, we have to tackle this issue by thinking of malware as a natural language processing problem. A natural language processing problem is basically, the NLP it's a branch of artificial intelligence that helps computers understand the human language, understand, interpret, and manipulate the human language. So basically, why do we tackle the malware detection using this technique? Because malware is made of vocabulary of terms. It's basically words. At the end of the day, it's words. We have a file. That file, let's say it's like a C code file. We have a list of vocabulary that we can extract from that file, and then we train our algorithm to understand the bad ones and the good ones. So we give it goodware and we give it malware, and then we train it to understand the difference and distinguish both of them from each other. Okay, so there is two ways to do it. There is a static approach and there is a dynamic approach. I will go through them one by one. Okay, but before that, I want to discuss some paper that actually was published in 2019. It's called Detecting Unknown Malware from Ascii Strengths with Nlp Techniques. So NLP is actually a recent technique used in, it was discovered, or it was implemented or developed for artificial intelligence. And it was published, this paper was published in 2019. And they use NLP to basically detect malware using Ascii Strengths. So what they did is they divided the strings into words, and then they distinguishes the difference of words between benign and malicious executable files using these techniques. And then they convert the corpus of frequent words into a vector, and they call it feature vector. Okay, the feature vector, it looks like a normal vector with the number of like, let's say how many times this word has repeated itself. Probably, I'm just giving an example. Okay, it's not like a real scenario, but it's an example. Let's say that this file it's probably loading some function called virtual allocation, for example. There's a Windows function called virtual allocation, which will allocate memory. It will allocate memory space for a process. Okay, so probably if that function got repeated in a file so many times, that probably maybe that indicates it is a malware. So this is one example of that. And actually they used 23,000 malware samples. They got it from different sources, and they used 16,000 benign files collected from downloadcnet.com. I think you guys know this website. I personally download from. So, and they achieved F measure more than 0.85, which is considerably high accuracy. Okay, and this is just one paper about NLP. There are so many papers that talks about NLP techniques. So I want to move to the next slide, which will basically explain how it is done. So we have malware files, and then we have benign files right here. And then we basically do the analysis. We do static analysis. We extract words from the static files, and then we extract, they call it feature engineering, or I call it feature extraction. They pull the features from the file. Of course, this is labeled. So I basically, it's a supervised machine learning. So I label this file as a malware file, and I label these as benign files. So I distinguish between them. And that is one of the challenges actually in machine learning, which I'll go through later on at the end of the slide. So then after we do feature extraction, we will feed this into our machine learning algorithm or machine learning classifiers, and then they will be able to dispose files based on the data sets that were fed to it in the training phase. And then in the future, hopefully, we hope so, that this unknown binary will be categorized as benign or malicious based on the data set we have. And of course, you guys, I know you have so many questions about this, and I feel like you can see how this can go wrong in so many ways, which I totally understand. And there are some challenges in this. Of course, it's not that easy as it's actually shown here. Okay, so moving on to the next slide, we have some advantages and disadvantages about dynamic and static approaches. So the static approach, where we analyze a static file, of course, some of the advantages of that is because it is safer to do that, because we do not execute the malware. We just statically pull the features or characteristics from it and then feed it to our machine learning algorithm. And this is also good because we can analyze execution paths of the binary. Also, the analysis and detection will be fast it will be faster than dynamic, because dynamic, of course, we have to run it in an environment and we have to wait and see what it does. And then after that, we can dispose this file. The disadvantage of this is because it is not good against packed malware. Packed malware is basically a malware where it is compressed, ciphered, obfuscated, not clear. When you look at the file, you don't know what's going on. So how do you go from there? It's going to be really hard for a static analysis or static approach to really dispose a file from looking at it. And we have the dynamic approach. The advantage of that, it will guarantee that the exact behavior will be looked at. So it's not gonna think about what's gonna happen, or it's gonna presume what's gonna happen or assume. It will actually see what happens. So the files that was opened, the internet connections that were made, registry edits, anything that happened during that time, it will be logged to a file. Okay, and then it is good it is good for you to understand how the binary behaves exactly. And the disadvantage of this approach is it can only analyze a single execution path. It will have a significant overhead because you need a sandbox, and you need or they call it an emulator. So you need it to be running, and then you will feed it the malware, and then the malware will execute it, and so it will be there will be some overhead over performance. And the last one is very important, which means malware can identify controlled environment. So some malwares, advanced malwares and advanced APTs, they understand that they are in a controlled environment, so they don't actually run. So when you try to execute them, they don't do anything. So that's one of the challenges exactly when thinking about doing machine learning. So I'll move on to the next slide to explain, to go over the feature extraction, how it does with NLP. So we have a file, exe file. We do NLP techniques. We basically do we pull information or words or vocabulary terms or whatever you call it. We pull it from the file, and then we do a feature vector, and then we feed that into the machine learning algorithm, and then it will learn like the frequencies and how the feature vectors of malware look like, and how the feature vector of goodware look like. In the dynamic approach, we will need to have a file, and then we run it in an emulator, and then the emulator will need to give us a log file, and then that log file we will use it to do feature extraction or feature vector, and then we do NLP, and then we feed that into the machine learning to make it learn the dynamic goodware and the dynamic malware, how they work. Okay, so as I mentioned earlier, there are some limitations of machine learning, especially when doing malware detection. So the first one is the potential of exploitation. So some attacker can potentially actually exploit this machine learning. It somehow the attacker can potentially find out how the algorithm disposes threats and as threats or as benign files, and then he can basically build a malware which will meet the benign file features or categories. Okay, and the second one is the requirement of a large, well-labeled data set, and that, as you guys know, it requires a lot of resources, and it is not actually, it is very expensive to do, and it's time consuming. So I'm sure there are some other limitations, but these are the limitations that I came up with, and I was thinking about actually how it can be harmful for when doing machine learning for malware detection. And this is actually the end of my presentation. And thank you guys so much.
Thank you so much, Saeed. Now we like to introduce our next speaker. This is Aideen Aslaner. Aideen is the head of security for Middle East and Africa. He's based out of Dubai from Microsoft. So over to you, Aideen.
Thanks very much. Thank you very much for all the previous speakers as well. You guys can hear me clearly?
Yes, very much.
Perfect. I'll just start sharing my screen as well. And then I'll start my introductions at the same time. It should be now this one. Just let me know if you can see the screen, please. Then I can.
It says you started to share screen, but we can't see your screen yet. Yes, now we can.
Now you can see it. Okay, perfect. Good. So my name is Aideen. I'm based out of Dubai. I do work for Microsoft for the last 15 years. I've been in the security business for the last, I'll say 25 years, but I just turned 22 last year again. So my experience is, and number one, coming from a technical background and hands-on, but then moving slightly, into the business development side and working a lot with governments and regulators in our region specifically. I had today only just 2 meetings with 2 different governments in our region, just to talk about the cybersecurity regulations in those countries that are going to be released soon, and how we can actually help them tailor it. But today's presentation, I really want to focus a little bit on where we see AI coming into this space as Microsoft, and I'll share a little bit about also my personal view on how things have developed over the last year, I'll say. Okay, good. You guys can see the screen. So let me move on to the next slide. So we've been seeing some, I think, changes in the world that we're in, right? We're in this unprecedented uncertainty. We have organizations of all type that needs to accelerate their transformation for productivity, for shifting customer demand and expectation, and data and information, is rapidly shifting the way we interact with each other. So that's one part. But this whole thing increases also the activities of the cyber criminals, and that's the biggest challenge that we're seeing. I'm not even talking about the global shortage of the cybersecurity skills that we have in the market. We're missing millions of people probably in this in this space, and it's great to see new talent coming in, but we need a lot more. In order to secure those environments, we really need to have companies, governments to develop new digital capabilities to break down these silos across multiple, stuff that we have to interact together, and that's across, applications, devices, people, everything that comes into play. And the traditional method of, protecting our environment, it doesn't really work anymore. I think Ola, touched base on a very important point about the, cloud-based firewall, and I think that's one side of the story, which is very, very important. And there's a lot more to that, but imagine how we were protecting our environment 20 years ago. We put a firewall in front of the door, and the door maybe whatever it is, and everyone would say, okay, we're secure. That world is gone, and I think it took a while until everyone realized that it was gone, and it's still in that motion of, okay, we need to change and we need to adopt to this new reality of how we are going to protect these siloed premises, tools, data sets that we have in our in our companies or in our environment, basically. So that's one part. The other part is, I think one thing is very clear: the modern technology, the way we are seeing it right now, and I think Dr. Wu, when he touched base on the fake news part, I think I liked it a lot. It is causing a shift in the behavior. People are able to address most of their daily needs at any place, at any time, on any device. Most of us are working from home right now. Most of us are probably having kids that are working or attending school remotely. And as a result, citizens are expecting more from their governments. They expect the governments to, to be able to interact as with their customers, like in the commercial space. They expect to access services quickly, efficiently, in any location, and the way it's convenient for them. So it is changing, and if we don't change the way we're interacting, we're going to be, left behind. That's one part. And then the other piece is, of course, the security aspect of this. In this world which is changing rapidly, how do we make sure that the data that we're collecting and the data that we're processing is managed in a secure manner? And how can AI help us in that, right? When you talk about security personas, and I'll take just a few minutes, I'm not going to go into the details of this, but we need to really understand, and this is how we look at it as Microsoft, on who are your threats? Where are they coming from? What is their motivation? And when you know these points, you can probably defend a little bit better against them rather than just guessing where to start. Not going to go into much in detail, but you have the first cyber criminals. Their motivation is, I would say, most of the time is financial, right? They want to make profit. You have the nation state actors who have been very active over the last couple of years. And I'm sure over the last year you have seen a couple of reports coming out from Microsoft, from other vendors that are sharing openly now which nation state actors are behind what attack and what disruption it has caused. You have then the hacktivists. There could be some political motivation, and that's where I think Ola's DDoS protection could come in very handy, because these hacktivists could be leveraging DDoS attacks in order to bring down an ISP, because their objective is to disrupt and cause chaos in a specific organization. And then you have the insiders, which are quite often forgotten, particularly because these are people that typically work in an environment, either government, commercial, or whatever it is, but might have a bad intention. It could be opportunistic, it could be not, but their efforts could be really something that people don't see a lot. And that's the biggest problem. So if you look at the attack vectors at the same time, and I think I'm going to call out one of them specifically because it was just recently in the news, supply chain attack. I'm sure you have seen the news about SolarWinds, SolarGate issue, where a lot of customers, a lot of enterprises, governments were in a challenging situation because of this breach, which was caused through a supply chain attack. And that's a bigger part of our work that right now we're focusing on, to how do we build intelligence services that can actually mitigate those attacks, right? And where do we start? Where do we really come in with intelligence services like AI and machine learning to learn and adopt our systems to respond to these attacks? So taking together everything we've outlined and shared the IT security, organizations really, I think, find themselves responsible, protecting and overlapping web of technologies, many of them which they not own even, or they're not the ones that are going to decide what's going to happen on them. So there's devices, different user groups, corporate data, perimeter-based security models. All of that comes into play, and then you're thinking about, okay, so how do we secure all of this? How are they connected? They are, this is a hyper mobile environment. We can't just put everything behind one firewall to be safe, right? There needs to be a little bit more than that. So we need security models, and I'm not going to go into zero trust discussion, but that's one model, of course, to look into, to adapt to the reality of the world that we live in. One of the things I'm going to highlight is, and this applies to any cloud provider, and I know Microsoft's logo is on the slide because I represent Microsoft, but one of the things that we inherit, by onboarding any customer to our cloud platform is we inherit two things. One, we inherit the regulatory requirements that the customer has, which is not too bad because then we make sure that the customer is compliant with it. But we also, inherit their adversaries. So whoever is trying to breach them or attack them is now going to start at least attempt to breach them on a Microsoft platform. And we are probably by far one of the most attacked customers, enterprise in the world. And we learn a lot from that. And I'll come to that piece in a bit and what we do with that learning. But this is something that a lot of people forget. You know, all these cloud providers that are out there that are providing a service, they learn a lot from their own environment, but they also learn from the customer's environment. And when I say environment, I'm not talking about the data points that are, you know, the data that is within the customer environment, but rather the telemetry that gets into that environment and how that telemetry gives us insights into how we can protect us and them better, right? Now, this is a real world example. This happened literally. Of course, the names have been changed, locations have been changed, but this is a real world example how we believe threat intelligence should work. You know, while we are definitely not always at this level on every scenario, this is, I would say, almost like a North Star when it comes to how threat intelligence should reduce friction, cost the productivity, while increasing the attacker's friction and cost. Because, you know, you want to always keep it in a balanced way where you make it so, you know, so hard or so expensive for the attacker to come in so that they actually lose that interest. This was a while ago, about 2 years ago, if I recall correctly. Was at one of the high schools in the US, you know, working on his Windows PC, you know, built in with the Windows email app, checking his, I think, Gmail account back then, received an email with an attachment infected with the new variant of the Emotet Trojan, which is very well known. He was actually the first one to encounter it in that case, and there was no signature that existed at that point to help identify this threat. What happened next was, let me just open up the slide. When you know, the teacher basically double click on that attachment, it was already too late. But before the attachment could open, actually Windows and the built-in mail client queried about 80+ cloud-based machine learning models to ask for a determination as to whether this was, you know, malicious or benign. And in parallel, the file detonated in an isolated cloud VM, so in a virtual machine, where an AI-based system watched to see what would happen if the file would have opened. Both the cloud models and the detonation service determined at that point the file was malicious and blocked it from opening, and then deleted it immediately from the PC. The file was then flagged for a human security analyst to review. So might be probably something interesting for you, Said, as you were talking about this. And all this really happened within less than 400 milliseconds. It's a blink of an eye. This is an actual customer issue, and you know, I haven't shared this one in the intro, but I used to manage the incident response team at Microsoft in my previous capacity, and this includes governments, you know, commercial customers that we actually help when they have an incident. And when I say incident, a breach, basically. And you'll be surprised, and I think Ola touched base on it a little bit as well, you know, how long it takes for a customer to really detect, or in a commercial or regardless of government, that they would be breached. It could be anything from, you know, a day, a couple of hours, to months, and sometimes it's a couple of months. And that gives the attackers a lot of time, of course, to navigate around the system. So this is one example on how we believe, you know, threat intelligence services powered by AI and machine learning algorithms can help, you know, to mitigate these. At Microsoft, we have access to a broad set of security signals that we use to generate threat intelligence and security insights. We train our artificial intelligence systems and machine learning models against trillions, really trillions of daily security signals that enable us to gain some advantages on attackers, often helping us protect customers before attack attempts become successful breaches. And that's very important for us, that we are ahead of the game. At the same time, and you know, people ask me a lot, you know, so what is the power behind that whole threat intelligence? It's composed of a diverse set of signal sources. We have over, and I know there are lots of numbers, I'm not going to go into the details of each one of them, but we have about 1.2 billion PCs, servers, and IoT devices that run variation of the, you know, Windows systems, operating systems. That includes, you know, the likes of HoloLens, includes Xbox, and they provide anonymized telemetry for us. Hundreds of millions of iOS, Android devices, macOS, Linux, IoT endpoints access Microsoft services. and we have more than 1 billion users that are using Azure Cloud Services. So if you combine all of that as an entry point of data to actually learn from, that's quite huge. And that's, I'm sure applies to a lot of other vendors in the space as well. But this is where the power comes from. You have a large set of data that you train your AI engine and your machine learning algorithms on, and then you respond to those attacks, and or you even predict them, because now you know how things are working, right? So that's one of the key points. Now, to be successful in threat intelligence, you must have, of course, that large, diverse set of data, and you have to apply your process and tools. And we try to do both, right? And I say we try because there's no such thing as 100% secure, as we all know. But the data that we collect from various sources, they pass through a strict privacy and compliance boundary to ensure that the data is only used in the ways the customers have agreed to, because that's a very serious thing for us. The data sources include, the products that I've just highlighted, and also, we learn from the incident response engagements that I've just highlighted as well. When we engage with a customer that had an incident, we sit down, we analyze data, we understand what happened, and we learn and feed that into the products and services as well. So that's one piece. The other piece is the data collection analysis, because once you have that, you have to go through some sort of a analysis to understand. We have to normalize that, apply various, techniques to identify relevant security insights and findings, and then publish that into an internal API. That's how we operate, because we have the data point. That's great. We learn from it. That's also great. But now we want to feed that into products and services. And I'll share a little bit more. Forget about the last piece at the bottom. These are Microsoft services, but the APIs that we publish for the intelligence security graph are also available through our GitHub. So anyone could basically subscribe to those threads, to those APIs, to actually build security solutions that are also getting the feed from Microsoft. And not to mention that we have also, of course, government security programs that we run. We have a digital crimes unit that is solely responsible to bring down botnets on the internet, and they learn a lot from these kind of attacks that are launched. And we also have, of course, the human aspect to this. It's not only going to be AI and machine learning who's going to be protecting ourselves, our environment, but it's also going to be a human interaction required at one point, where you have probably a SOC team. In our case, it's the Cyber Defense Operations Center at Microsoft that is responsible to look into all the data points that have been run through all these intelligence systems, and then put on top of that their own experience into it. We have over, I think, 4 trillion files in our malware sample zoo. We collect about 8 million indicators of compromise daily. So there's a lot rich data that we learn from, and we feed that into our products and services, and we share that with our customers through different programs. And I'll go to my last slide, and this is not something from us. It's not Microsoft saying it, but it's Forrester who actually put this up, and I want to really put my signature on it, and I want to sign up on this. Taking together everything I've highlighted, I know we've been going through this quickly, but the trends that we're seeing, the challenge that the IT security is facing, I don't think there is any way for us to protect any environment, and I would say any commercial, government, private, consumer even, by just using all traditional methods. 20 years ago, we used to protect with maybe a firewall. Then you had some antivirus software. That world is gone. You have to have intelligent solutions that are going to be able to keep up with the pace of the technology evolution, the transformation to a digital world, and where consumers and citizens are demanding access to data at any point, at any time, but they want also security. And I think that's where the power of cloud will come, or is coming, where you need to have that engine that can scale, unlimited at a rapid speed, learn, and then feed that into that learning into that product and service that they're servicing. And that applies to any vendor, not limited to Microsoft. With that, I'll want to thank you for giving me the time to present, and hope this was valuable for you.
Thank you, Aideen. That was a very great presentation. Thank you for providing us with that. great to hear from you, and a lot of useful information and knowledge, I think, that many organizations can learn from you on. Can we please call up our next speaker, who is Bilal Isa, who is the technical lead at Trend Micro, who are based in Qatar, but of course operate internationally. Over to you, Bilal.
Thank you so much. Quite interesting event, and I felt myself I have learned a lot from this event. So I'm Bilal. I'm the technical lead for a passionate team of cybersecurity experts in the Gulf cluster, covering several countries. One of them is lovely Oman. Today, I'm gonna talk about machine learning, AI, and cybersecurity benefits, practical benefits, how customer perceives the result of what goes on in the back end, and how cyber criminals are abusing AI when it comes to cybersecurity. Before I start, I have two questions. So will artificial intelligence be the end of us as humans, or will it significantly improve our lives? So according to looking at Gartner's hype cycle, it looks like it can be both. And the other question is, will AI take over cybersecurity? Similarly, looking at the hype of Gartner report, it looks like artificial intelligence, it will have a more prominent role in digital security in the upcoming years. I believe AI is becoming an integral part of the cybersecurity industry. In my presentation, I'm not going to go through the details and types of different machine learning algorithms and implementation of AI. I believe Dr. Wu and the other colleagues on the panel has done a very great job in explaining such. However, today, AI and machine learning can be indispensable in cybersecurity. AI can predict and fend off cybersecurity attacks more accurately than people, since, as we all know, it processes a huge amount of data more fast than humans can process. And it also frees up cyber operations to focus more on other complicated tasks. Machine learning can be effective against detecting malwares, can be effective in network monitoring and recording user behavior, and then alerting when there is any change on the baseline. According to Forrester report, AI can help in dealing with critical vulnerabilities at a 4% more quickly than the usual manual solutions like patching, manually patching, downtime, granular change control, etc. Having said that, let's look at the dark side of AI. So today, AI, as AI has revolutionized cyber defense, but at the same time, it has put new tools in the hands of attackers, from automated malwares to deepfakes, and the use of AI has already impacted the threat landscape of our today. We as cybersecurity professionals, we all agree that AI will continue to disrupt the cybersecurity landscape in a very fundamental way. Similarly, AI has helped in the increased return on investment and the speed of an attack when it comes to cyber criminals, which is an advantage for nation states, cyber criminal gangs, and hacktivists. But today, AI isn't necessarily all-in powerful solution to end cyber attacks due to several challenges. Number one, AI or artificial intelligence is not invincible. Some tasks performed by AI can also be manipulated and replicated by cyber criminals. Another challenge is that AI possesses a huge amount of money, time, and effort for organizations to implement in their infrastructure, to integrate in their ecosystem for detection, prevention, and so on. And this cost associated might force back companies from implementing AI on their by themselves. However, today, if I look at AI, I would say it's a double-edged sword. We have this Damascus stainless steel sword where you can hit on both sides due to several reasons that we have practically seen in the field. Number one is the usage of AI by cyber criminals when it comes to identity theft. So deepfake attacks, impersonation in social media, and so on. Data poisoning, where cyber criminals were trying to train machine learning algorithms of cybersecurity defense organizations in order to trick their integrity, compromise the data set, and have their malicious component or malicious code being tagged as a safe file or a safe executable to run on machines. GNA or generative adversarial networks. This is where two AI systems compete. One is executing the normal routine. Other is finding mistakes or spots that are not properly executed in the first AI system. Due to this competition, we can have a feed which can ultimately compromise the original AI system in order to be tricked or to deliver or to execute different behavior and so on. And bots, usage of automated bots for different reasons, changing, like Dr. Wu has mentioned, social media bots, doing attacks on social media for reputation and so on. One of the cases I've read about is the cryptocurrency attack, where hackers have learned how bots are trading on that cryptocurrency system, and they trick the algorithm for their benefit. References here, two nice research reports that we have published. It goes more granular and deep into different subtypes of how cyber criminals are abusing AI in the wild. A live example, 3 years ago, since we monitor our machine learning algorithms in the back end, we have seen several attempts during the Sality ransomware and Sality worm spread. We have seen several spikes which we have detected as attempts by cyber criminals to poison our detection machine learning for that attack. So it was quite interesting. If you look at the norm of the graph, so detection, positive detections of server or client-side infections, and then you have those spikes where files were sent in a massive amount back to our data set in an attempt to poison our machine learning capabilities. So today, how do we deal with those compromises or those abuses of AI in our environments? We all agree that today attacks are developed in modules, a C2 module, a persistence module, an exploitation kit module, and so on. And this actually introduced offensive artificial intelligence into the picture, where it allows cyber criminals to drastically increase their stealth and persistence in the environment. The problem when it goes back to the organization, so back into the field, we have seen that attacks, modular attacks, do not stay in silos. So part of that attack will target the endpoint, and then another part of that same attack will do lateral movement to a workload or a server. From the server, it creates different services, creates other payloads, tries to laterally move, tries to do a privilege escalation, and tries to exfiltrate data. This includes different silos in the environment: the endpoint environment, the workload environment, the email system, the web or the web traffic, the network traffic, and so on. And AI compromises in each and every silo by itself has successfully proved that it is not the way ahead to detect such modular attacks. So imagine if you have endpoint or EDR security, and then it is bypassed because it is based only on machine learning, or it is evaded, and then it has no connection with the other layers in the environment. This brings us to a list of challenges where today security analysts and SOC, security operations centers, strive to prioritize incidents, try to come up or document the impact, what has happened, when it happened, where it happened, how it happened, and so on. And ultimately coming up with recommendations to close the gaps and eliminate risks to maintain a healthy cybersecurity posture. I have to disagree with Aideen on the part of threat intelligence. So today, this terminology of logs, threat intelligence, put them in a blender, and then pray for a detection is not anymore effective. It is leaving enterprises, instead of looking for a needle in a haystack, it's leaving enterprises with different haystacks, and then they need to decide which haystack they need to choose in order to search for those needles. The solution today for those modular complicated attacks is for sure coming back to the pyramid of pain, where we detect and prevent tactics, techniques, and procedures, ultimately making it more harder and complicated for cyber criminals to infiltrate or compromise enterprises. This urged us to push our technologies as cybersecurity organizations from detecting well-known attacks via filters, signatures, rules, etc., into detecting unknown attacks by utilizing machine learning, whether it is a supervised training set or unsupervised machine learning training set. And on top of that, this analytics of the data stacks from different layers in the environment. So we are moving from a prevention of known threats, where we install the technology and forget about it, into a more of collaborative strategy where XDR is introduced into organizations to detect unknown threats, utilize machine learning not only for detection based on the silos, but also for correlating telemetry, correlating detections from different silos, and coming up with this needle out from that haystack, which actually increases the reliability of detection, response, triage, and forensics or investigation in an environment. Why XDR? Because it is a layered approach. It's based on context, very important element. It combines statistical and behavioral detections. It can be implemented locally, on-prem, for organizations who are pushing against the cloud. And it also can be used or utilized in the cloud. An example of how context is being used to eliminate risk is based on behavior. Today, if I have a fish and then I'm cooking that fish, the expected behavior is having that fish being eaten as lunch, etc. If I have that sample and I put it in a bowl of water, my behavior is to have this fish as a pet. So today we are utilizing AI and more advanced AI or security analytics model that utilizes the detections of different machine learnings on different silos in order to predict the risk and recommend automatically the technology layers or the cybersecurity controls to get back to this platform with the telemetry required for that specific detection model to be triggered and generate visibility for the end user. Machine learning in XDR allowed us and our customers to achieve or to give answers on who, when, where, and what an attack has happened. All of those collaborative controls and AI machine learning engines are part of one platform that we have in Trend Micro, which is the Vision One. So we are not anymore pushing TI, threat intelligence, into each silo separately, running machine learning, and then generating a detection only at the silo level. No. What we are doing now is way advanced by using machine learning on top of a data lake, which is collecting telemetry from those different silos and then predicting for a detection of an attack, which we have a high fidelity rate than having this machine learning run on those different silos by itself. So imagine today you are correlating a bigger data set from different silos in the environment, and then you are curating data from that data set, running machine learning algorithms on that curated data set to come up with curated fidelity detection, which actually decreases the time to conclude an incident in an environment. So when I say conclude, it means that it decreases my mean time to detect an attack, mean time to respond to an attack, and mean time to contain and have my production up and running back. Now, how, in a high level, how does this algorithm work? So raw data, telemetry, detection alerts from different silos, curated data is chosen, expert rules, machine learning, and analytics is executed on that data set. And then we come up with correlated detections, which actually is being sent to the customer as an alert or a conclusion of what was happening in his environment about a certain cybersecurity incident. This platform is quite cloud native, so it was born in the cloud. And it will continue to evolve in the cloud. I agree with Aideen when he said that, or Forrester when they mentioned that the future of cybersecurity is in the cloud. Yes, due to the limitation of infrastructure that separated organizations might inherit in the wild. Such platforms enhances security operations center response times, it enhances visibility, it enhances detection, and it also introduces integration into a bigger ecosystem where customers will benefit from their existing investments. An example of I've took from our R&D. So we have in our XDR for one customer with 1,000 device, 24 hours. Imagine we have collected 137 million log. We have identified, based on our curation, around 40 million logs to analyze. Those logs were analyzed. Detection logs were filtered because those are confirmed logs. And then we got around 33,000 filter hits on those engines which inherit machine learning and security analytics. And then we came up with 3 detection model hits, where a detection model looks like this. So it contains different curated behavior from different silos in an environment to come up with a fiddle, accurate detection in an organization. This is how an incident responder or a SOC analyst would view such curation or detection model triggering. So email involved, workload involved, lateral movement involved, execution of fileless or lulls, living off the land attack on the machine, and for sure curation or correlation with different endpoints from different workbenches or incident view can also give a better idea of what has happened in the environment. For this, I come to an end to my quick presentation. I hope that I have not overloaded you with information. I myself felt I learned a lot from all of the panelists and presenters, and I will be glad to answer any question. Back to you, Amr.
Shukran, Bilal. Thank you. Of course, there was a lot of information there, and I always expect that from you as an expert. We're always great to hear from you. It was very exciting, and it's always good to see different views shared and ideas shared. So thank you for making that nice and engaging and thought-provoking. I'm looking forward to the Q&A with you as well. So now we'd like to bring on our next speaker, who is Aideen Hamoudeh, who is the Senior Operations and Response Technical Lead at IBM Security Systems in the UAE. The floor is yours, Aideen. Thank you.
Yeah, thank you very much, and good evening, everyone. So a quick round of introduction. So my name is Aideen Hamoudeh. I look after our security, intelligence, and operation here, based in Dubai, but I'm covering the region. Let me start my presentation with a quote that does really a great job of capturing of how security should look into AI. It says that the greatest potential from artificial intelligence will come from tapping into opportunities for mutual learning between people and machines. If today we look on how people are seeing AI, I mean, the first image that comes to their head is just a scene from the movie Terminator where machines are taking over. But in reality, in order for us as a security community to have a workable AI, we need to leverage and stress on the importance of tapping on the mutual learning between people, data, and machines. And we need to set the stage on what AI means for us. And AI means for us is security augmentation. And when we say security augmentation, we are disputing the arguments around having machines replacing people eventually. So if we take a closer look at the threat landscape today, I mean, adversaries, attackers are already using AI to defeat cybersecurity, whether this is AI-powered attacks or whether this is attacking the AI engine itself by contaminating the modules or poisoning the data. And on the blue side of AI-powered defense, we need to start proactively in our detection, and a response. We also need to be prepared for counter-measuring adversarial AI. We should have the capability to detect contaminated modules or machine learning modules, poison data within these modules. And the way forward here is that leveraging AI today that is bringing speed and accuracy into three main pillars. First one is proactively protecting and tracking your high-value assets and information flow across the organization, and continuously evaluating risk posture by enforcing policy proactively. Secondly, accurately detecting by leveraging existing machine learning algorithm, whether it is supervised or unsupervised, especially now with the increase of AI-powered attack and, for example, the introduction of IoTs, 5G networks, hybrid cloud, and multi-cloud. Lastly, accelerating response. And this is where we need to automate investigation leveraging AI. I need to leverage AI to provide me advisory and recommendation into my day-to-day security operations. I need to leverage automation whenever is possible when I'm planning for my response or security orchestration and automation. And what can we do today? I mean, today, tools are providing us with these capabilities. So today we have two existing tools that can provide us with the capability to proactively protect by leveraging the data classification based on neural network and deep learning, by leveraging the automatic detection and policy enforcement, for example, with role mining and techniques. As an example, biometric behavioral. Today, we have the capability, for example, to predict and protect access control based on the behavioral detection or behavioral anomalies of users. So if something suspicious or something abnormal, I can block access or I can grant access. On the detection side today, we need to leverage existing machine learning algorithms, supervised and unsupervised. We need to incorporate these machine learning algorithms into our day-to-day security operations. We need to fine-tune them for better results, for example. As an example here, UBA, or User Behavior Analytics. UBA today is giving us the capability or the ability to learn the normal activities of the users and detect the abnormal activities of the users based on unsupervised machine learning algorithms that can profile the normal activity for the user. And also now we have machine learning algorithms that can detect access activity, for example, the activities for the user versus his peers on the organization. So we can dig deeper into these machine learning algorithms, fine-tune them according to our business. Lastly is accelerating investigation and response. And this is where we need to incorporate AI-powered engines into our day-to-day security operations. I need the AI engine, and today tools are providing you with these capabilities. I need the AI engine to tell me what is the offense. I mean, have I seen this offense somewhere else in the world? who are the threat actors behind this offense? Is this offense or attack is relevant to my organization or is relevant to my network? What do I do with this offense? Do I close it? Do I escalate it to an L1, L2, all three? So we have the capability today to leverage AI in performing these activities. And lastly, on the response side, automation is key here. We need to leverage automation whenever it's possible. By leveraging automation based on AI capability to take the decision, for example, based on the proactive workflows that comes out of the box and built and is being built proactively, leveraging AI and artificial intelligence. So this is great. I mean, we already have tools that is doing this these days. We at IBM have these capabilities for a long time, and I'll be more than happy to dig deeper into each pillar and show you what exactly we are offering in terms of capabilities. But we as a security community, we still have a big challenge with AI. And the reason for that is that as of today, we don't have a unified way of how security is communicating, right? And this is where we say there is no AI without IA. And IA here stands for information architecture. So information architecture is the architecture design of the organization information on how they can tackle data and perform activities, for example, like analytics, searching, and reusability. And in order to do this, we need to have a standard way of communicating security. And unfortunately, we don't have this today due to the nature that security is still fragmented, disconnected, and especially now with the introduction of cloud, multi-cloud, and hyper-cloud. I mean, a typical client these days have from 20 to 30 various security tools from various vendors. And these security tools don't have the capability to seamlessly integrate or talk to each other. They do not give you the capability to have the bigger picture of seamlessly integrating these various tools. And also, unfortunately, some of these tools from the same vendor, they don't speak the same language. So what if security can be unified and connected? What if security teams will have the capability to have visibility into the bigger picture of data and of security data? And this is where I'm pleased and I take pride of being an IBMer, that IBM is one of the co-founder of an open source project called Open Cybersecurity Alliance, or OCA. The whole purpose of this alliance, I mean, I think when we founded this alliance, it was like 3 or 4 vendors. Now we have more than 30 vendors who came along to participate on this. So the whole objective and vision of this alliance is to standardize the way security is communicated. So we need to come up with a standard ways on how to communicate security seamlessly across various vendors so that we can give AI or machine learning algorithms the true power of unlocking the security data. I'm not gonna dive into the details of OCA. You can do a Google search on Open Security Alliance. But when we dug deeper into the cybersecurity field today, we found out that the only place that security is standardized is with threat intel exchange. I mean, today, if you want to ingest threat intel data, or if you want to feed threat intel data, or if you want to write threat intel data, you have certain standard ways or protocols to do this. And what we did is that we built a wrapper protocol on top of Styx and Taxi. We call it the Styx shifter. And the whole purpose of this new protocol is to wrap the communication from source to destination across various vendors. So today, if Trend Micro wants to talk to IBM, the information can be wrapped through the Styx server. If Microsoft wants to talk to IBM, if FireEye wants to talk to IBM, the information can be exchanged seamlessly without any complication of, for example, integration and the complexity of the integrations. So for my last slide, I'm going to keep it light for you because I think we're already overdue the top of the hour. We at IBM have been helping clients for many years now. I mean, with the introduction of artificial intelligence, and if you guys keep track of Watson and Watson artificial intelligence and what we're doing with Watson, with winning human debates to healthcare, to pharmacy, and now we are introducing Watson cybersecurity when it comes to cybersecurity. So we are been helping client detect faster, and we are be helping client to reduce and respond faster to attacks from hours to minutes. With that, this is the end of my slide. If you guys have any questions.
Thank you very much for that, Ayman. That was great, very intriguing, some very advanced information there, so thank you. So now we would like to move to Dr. Sheng. You're on mute, Doctor.
I'm going to stop sharing the screen. We can see
I'm just trying to find out how can I just found it.
How to stop sharing.
So I have, oh, okay, yeah, I found it.
Yes, yeah.
Great. Yeah, now open to the audience. Anybody have any question? Please say through the chat, and I will repeat a question to the panelists and let them explain to you. Any question?
Yes, they can. If anyone has a question, you can please send it in the chat or the Q&A, or also you can raise your hand and we can give you the video.
Well, let me start with a question. Is that we will talk about a lot of this external attack, cybersecurity external attack, the malware or whatever, ransomware coming from outside. Well, how do we protect against insider threat? The threat coming from the inside. In America, the biggest example is this Snowden working for NSA, National Security Agency, and steal all these top secret communication and then put it on the website. And that's what the beginning of the WikiLeaks. So how do we protect against insider threat? And that's in one of the component in Aideen's slide. Any panel want to take up this question?
Yes, sure. So that's a very interesting question, actually, and it aligns with what is being planned for and implemented too nowadays. So if we look at zero trust today, where you don't trust any connection, whether it is internal, external, insider, outsider, VPN, etc., and verify, this is where you are covering not only insider attacks, you are also covering attacks from legitimate connections to the environments, like suppliers over VPNs or over MPLS connections. So I believe zero trust is an important control to implement today in order to prevent, detect, and respond to insider and other attacks.
So the question is, what is the cost of a zero trust in terms of operation, in terms of performance, in terms of what is the cost to that?
Great question. So the cost today is incubated inside the layers or the technologies that customers are using. Each and every vendor is upgrading their security controls, or security layers to include zero trust configuration artifacts and zero trust configuration elements. Cost, I will believe, is more on the mindset or strategy of how information security department in an organization will respond to implementing zero trust in an organization.
Thank you, Bilal. I have the next question for Ayman. Ayman, you talk about there's some kind of open, forum that people can share the information what you learn. I mean, it makes sense because everybody machine learning based on data set. The more data set you have, different data set you have, you learn more. If we can share, then we can leverage all the technology capability of different vendors. But on the other hand, that go against business because cybersecurity is a big business. And so will people, a question to Ayman is, will people really openly share what they learn and then exchange information? Oh yeah, please watch out for this signature. When you see this, this can be a bad thing. So how do you handle that?
Yeah, sure. Great question. So when we started the OCA, or the Open Cybersecurity Alliance, there were 3 to 4 vendors on board. And if you check today, we have more than 30 vendors onboarded already. And the whole idea here is that at the end of the day, security is all about collaboration. Security is all about building the ecosystem. I mean, no one can survive alone in security. I mean, I cannot go and say, you only have to take IBM and you will be protected. Security is all about collaboration. Security is all about building that ecosystem. So in a one way or another, this is have to happen, right? So the formalization or the unification of security and standardizing the way we talk about security, this is a must that it will happen sooner or later.
Yes, and totally agree with what your premises. Security is everybody's best interest, but because it's a big business, so there's a conflict. So I may want to join the alliance just to learn from other people, and then so that's a conflict. So anyway, I'm not, I don't have a solution for that, but that's a classic example.
I think Mr. Ola Lindt has his hand up. He's raised his hand for a question or comment.
Actually, I would like to add one thing, because we come from and we are talking about organizations and bigger pictures. But what I think is one of the most important one, and is that 60 to 80% of all businesses is small and medium businesses, meaning that is micro businesses, small businesses that is fueling the economy in every country around the world. And there is a big lack, and I think both from the government side and from the operators itself, because that's the weakness when it comes, say, zero tolerance or whatever, is that a weakness in a small company that do not see the threats, because they are obviously digital imprints, do not understand and will not take the action to do something until it happens. And the problems also is always when we talk zero tolerance in any organization, but specifically small and medium, is all human. I mean, I have a friend, or you're my friend in the office, or I bring a USB stick to the office and I utilize it, or I use my device from the outside in the environment inside the office, and something will happen. So the human factor will always be the weakness in here, but also the awareness from government, I think, is very important, and solution from bigger organizations like Microsoft, like IBM and others, is the educational part for small and medium businesses. I think is a very important important part, because that's where the easy preys are on an ongoing basis when it comes to phishing attacks and data theft, when it comes to banking information and so on. And I see that all over every region, every country around the world. Even here in Dubai the other day, when it came to Dubai coin, for example, in crypto, where they phished attacks of saying that it was a government approved coin, crypto coin, and they did it on a Thursday afternoon, when obviously on a Friday there is a holiday, so there is no action going to be done within a few days. So I think that's when we talk also about collaboration. It has to be not only for big organizations, but it also has to trickle down to the small and medium and micro businesses. And I think that's a responsibility we all have to implement and educate in all part of the ecosystem.
So Ola is absolutely right. There's an echo somewhere, but anyway, the education is one of the most critical component of these cybersecurity things, because the strengths of the cybersecurity, it's its weakest link. Think about it. In the US, the Colonial Pipeline got shut down for a week, for 5 days, because one of the employee clicked some simple link from somebody, and then it basically shut down the whole system. And so basically education, not just, I say, the strength of the cybersecurity is the weakest link. So education become very important, but I don't think, we see a lot of news, but there's not enough education talking about things you don't do. You know, for example, don't click anything. You will never get infected. Something like, don't click anything from people you don't know. But even that have a problem, because sometimes your friend's email address got hijacked, and then you saw from your friend, you start clicking, it's a picture, no, it's a malware. Anyway, any more questions from anybody?
No questions seem to be coming in. I think you guys must have been very thorough in your presentation.
Well, thank you for all the panel. I learned a lot, because I'm not from that space, cybersecurity space. I'm more from the other side, the application side. But it's great. I learned a lot, and hopefully we will have a chance to see each other again in different location, different conference.
Yes, for sure. And if there's any questions from any of the delegates who want to ask any questions in private, feel free to contact us, and we can forward this on to our speakers and our panel. We actually got the good news just a few hours ago that live exhibitions and conferences are now allowed in Oman again from today. So for our future upcoming events, we would love to have you here with us physically. So let's see how we can do that. And because of the great response we've had with the overall COMEX event, because there's an exhibition and awards as well, we're looking to roll out a series relating to different types of technologies, but more deeper into AI. And of course, cybersecurity will feature very, very heavily. So expect to hear from us, not too far in the future. And again, thank you for everyone for your inputs. This recording will go back to the team, and we will share it on our social media and through our networks as well. So thank you everyone again.
Okay, thank you guys.
Thank you so
Thank
much.
you.
Bye.
Thank you.
Bye-bye. Take care, everyone.
Bye.
Thank you very much.
Bye.
Bye.
Bye.